In number one, we want to find the distance between 2 points. So first we're going to line up the points. So that we have the x's and the y's lined up. And we'll write down the distance formula. So we're just going to subtract x's here in parentheses squared and then subtract y's. So let's do that. So here are our x's, so we're going to do minus 2 minus 1. And here are our y's, minus 4 subtract minus 5, that's minus 4 subtract minus 5. So this is minus 3 squared. And this is minus 4 plus 5. Just write that underneath. Minus 4 plus 5 squared, so that would be 1 squared. So we have the square root of 9 plus 1, and the distance is square root 10. In number 2, we're looking for a midpoint. Let me write down the midpoint formula. So the midpoint between 2 points is obtained by finding the average of the x-coordinates of the 2 points and the average of the y-coordinates. So again, it's useful to line up points so the x-coordinates and the y-coordinates are lined up. And now we'll just fill in. All right, we're going to add the x's and add the y's. So we have 5 over 2. And here we have 2 over 2. So we have as our midpoint, we have 5 over 2, comma 1. Here we want to find x and y intercepts. So to find an x-intercept, we set y equal to 0. So there we would have 0, put a 0 right here, equal x squared minus 5x minus 14. Okay, so we're solving this quadratic. It's in standard form, so we're going to try factoring. It factors into x minus 7, x plus 2. Let's just check. Over here we do get a minus 14, last. And for the middle, minus 7x plus 2x is a minus 5x. So that's the right factorization. Setting each factor equal to 0, we get from the first, we get the solution x equals 7. That's one x-intercept. And from the second, x is equal to negative 2. So that's the second x-intercept. So those are the two x-intercepts. Now to find the y-intercept, we set x equal to 0 in this equation. So we have y is equal to 0 squared minus 5 times 0 minus 14. And that's just y is equal to minus 14. So that's the y-intercept. Let's write these in point form. So this y-intercept would be 0, comma, minus 14. And these two x-intercepts, x equals 7, could be written as 7, comma 0, the point form. And here, x equal minus 2, that would be minus 2, comma 0. Number 4 says test for symmetries. Okay, that would be x, y, and origin. So first, let's do, let's say we start with y-axis symmetry. So what we do here is replace x with minus x and see if we end up with the same equation. So let's do that. So we'd have y is equal to 2 times minus x, subtract minus x cubed, divide by minus x plus minus x to the fifth. All right, so here, let's simplify a little bit. Here we have minus 2x. And here we have, when we cube this out, we get negative x cubed, and we have a negative over there. So the two negatives give us plus x cubed. And here we have minus x. And here when we open parentheses because of the odd exponent, we have minus x to the fifth. Now compare this to the original. It doesn't look exactly the same, but we do notice that if we multiply top and bottom by -1, we will get this exactly. So let's do that. If we multiply this by -1 and this by -1, multiplying top and bottom by the same number does not change the fraction. Okay, so here we get 2x minus x cubed, and in the denominator we get x plus x to the fifth. Now this is the same as the original, so we're going to say yes. Yes for y-axis. Now let's do x-axis symmetry. Well, then we would just replace y with minus y. And here we see right away that the result is not the same as the original. So for x-axis symmetry, the answer is no. And now for origin, we do both. That is, replace x with minus x and replace y with minus y. So we get on the left negative y, and on the right we have minus 2x minus x cubed, and here we have minus x plus minus x to the fifth. Now we saw over here that when we replaced on the right hand side, replaced x with minus x, we saw that we do end up with the same expression. So we have minus y is equal to, again, if you multiply top and bottom by -1, we will get this. And this is not the same as the original because of this minus y here. So no. In number 5, we want to find the center and radius of this circle. So we're going to complete the square in x and y. Start by putting the minus 10x next to the x squared and put a blank in for completing the square. And rearrange with plus 2y next to y squared and put in a blank for completing the square. Then subtract 1 from both sides and put in 2 blanks. And now we'll complete the square. Half of 10 is 5, squared is 25, so that goes here. And half of 2 is 1, squared is 1. So on the right side, we're also going to add the 25 and the 1. All right, now let's factor these as perfect squares. So this is x minus 5, and this is y plus 1. And let's remember that the 5 is h, and here k, which is the y-coordinate of the center, is -1. So the center is, if this is negative, the coordinate will be positive. The center is 5, and this is positive, so the coordinate will be negative. It's the opposite. Center 5 minus 1. And this is the radius squared, so the radius is square root of 25, which is 5. In number 6, we want to find the equation of the line through these 2 points. So we're going to use our formula y equal mx plus b. To start with, we want to find m. So we'll use the slope formula. M is equal to, remember, subtracting y is on top and x is on the bottom. So let's do that. I like to line up the points. You can put either one on top. Okay, so we have the slope is equal to subtracting the y's, 4 minus 7, and subtracting the x's, minus 2 subtract minus 1. So we have 4 minus 7, that's negative 3, over minus 2 plus 1. That's negative 3 over negative 1, or 3. Slope is 3. So we're going to put that here. Okay, so we have y is equal to 3x plus b. And now to figure out what b is, we'll use, let's say, this point, either one. For x, we'll put minus 2. Substitute. For y, we'll put 4. And that'll enable us to figure out b. So we have 4 is equal to 3 times minus 2. That's minus 6 plus b. Add 6 to both sides, and we have b is 10. And now we'll just complete this equation. And we have y is equal to 3x plus 10. So that's the equation of our line right there. Now we want the equation of the line parallel to the y-axis. Well, let's see if that is a horizontal or a vertical. So we just do a little sketch. Here's the y-axis. A line parallel to the y-axis is vertical. So once we realize it's vertical, let's write down the form of the equation is going to be x equal. And just pick off that x coordinate, and the equation of the line parallel to the x-axis and through this point is, parallel to the y-axis and through this point is x equal 2. And now we want the equation of the line perpendicular to the x-axis and through this point. Okay, let's see what we're talking about here. Here's the x-axis. Perpendicular to the x-axis is again a vertical line. And again, equation of this form, x equal a. Okay, so once you recognize that we're talking about a vertical line, pick off use this form, x equal a, pick off the x coordinate, and we have, as our equation, we have x equals 7. Now we want to find the x and y intercepts of this line equation. All right, that's 2x plus 3, that should be 2x plus 3y equals 7. Let me correct that. 2x plus 3y equals 7. So let's remember that to find an x-intercept, we set y equal to 0. And to find a y-intercept, we set x equal to 0. All right, so if we set y equal to 0, then this is going to drop out. This 3y is going to drop out, and we end up with 2x equals 7. Divide by 2, and our x-intercept is x equals 7 over 2, or 7 over 2 comma 0. To find a y-intercept, set x equal to 0, so this is going to drop out, and we have 3y equals 7, or y is equal to 7/3, or 0 comma 7 over 3. And then number 9, we want to find the slope of the line that is parallel to this line. Well, lines, if it's parallel to this line, it has the same slope. So first, let's figure out the slope of this line. It's going to be the same as the slope of this line. And to do that, we must put this in the form y equal mx plus b. That is, we're going to solve for y. So we have 3x minus 2y equals 7. Just subtract the 3x from both sides, or bring this 3x over as a minus 3x. So we have minus 2y is equal to minus 3x plus 7. And now continue solving for y. Divide by minus 2. And we have y is equal to minus 3 over minus 2, or 3 over 2x, plus 7 over minus 2, or let's say minus 7 over 2. So the slope is 3 over 2, and that's going to be the same as the slope of a parallel line. Parallel lines have same slope. And in number 11, we want to find the slope of the line that is perpendicular to this line. So this line is 7x plus 5y equal 2. So first let's find the slope of this line by putting it in the form y equal mx plus b, or solving for y. So subtract 7x from both sides, or bring that 7x to the other side as minus 7x. And now divide both sides by 5. So we have minus 7 over 5x plus 2 over 5. So the slope that I'm going to write down, the slope of the perpendicular line, is going to be the negative reciprocal of this slope. So that would be positive 5 over 7. That's the negative reciprocal.